Good morning, everyone. Am I audible? Please mention in the chat box whether I am audible clearly or not. Okay, so I am audible? Okay. So everybody has joined? 30 students. Okay. Okay, so that day on Saturday, I have shared 4 documents with you all. I hope everybody has got that one. Okay, regarding your this class notes. Okay. So I think one more from the treatment chapter I am about to share. Okay, that's in my old laptop. When I will get the laptop after servicing, so I will provide you that notes. Okay. So activated / process. I don't know. I have shared with you or not. So that one, if not shared, then I will share with you. By whenever I get the laptop. Okay, so till now this water purification chapter I have given you the notes. Okay, 4 documents. So if you have I think Sierra have shared with you all. Okay, if not, then please share it. Okay, so till now, last class we have studied about the disposal by dilution. Okay, what are the conditions that are favoring for your disposal by dilution? Then again, we have learned about the dilution factor. Okay, and also we have learned about a term known as your self-purification phenomenon. Okay, so self-purification phenomenon we have studied. So what is it? That when that sewage is it is discharged into the river stream, so what happens, the receiving water, or you can say the river stream, it gets polluted. Okay, because of the waste products that contains in the sewage. Okay, but this condition, that the polluted condition, it doesn't remain for very long. Okay, because the natural forces of purification, so there are different forces, natural forces of purification, like your dilution, sedimentation, oxidation, reduction in sunlight. So all those processes, they go on hand to hand. Okay, they go on acting upon the pollution elements, and then they bring back the water of the river stream or the receiving water to its original condition. Okay, so that is a process that is known as your, like, it is an automatic purification of polluted water. So that is known as your self-purification phenomenon. Okay, so there are various natural forces of purification. We have just learn the names. Number 1 is your physical forces. So within physical forces, 3 forces are there. One is your dilution and dispersion, then sedimentation, and then the third is what? Sunlight. Okay. Then within chemical forces, 2 processes are there. Number 1 is your oxidation, and number 2 is your reduction. So now we will come to dilution and dispersion. Okay, so what does this dilution and dispersion mean? So like when this organic matter, okay, when this organic matter, it is discharged into the river stream. Okay, it is discharged in the river stream. So what happens? It gets rapidly dispersed and it gets diluted also. Okay, so the action or this results in, so due to this discharge, it results in diminishing the concentration of organic matter. So it minimizes your concentration of the organic matter, and then it reduces the potential nuisance of the sewage. Okay, then again we have one formula like we can find out the concentration of the mixture of the sewage and the like water. Okay, so we have a formula. You can see that the formula is C is equal to CSQS plus CRQR divided by QS plus QR. Now what is CS? It is the sewage concentration. Okay, what is QS? It is the rate at which the sewage is flowing. Okay, then your another one is your CR. So what is CR? It is the river stream concentration. Okay, river stream concentration. And what is QR? It is the river stream discharge rate. Okay, and then what is C? C is your concentration of the resulting mixture. So using this formula, we can find out what is the concentration of the concentration of the mixture of the sewage and the water. Okay, and this equation is applicable separately to concentrations of different impurities such as what? Oxygen content, BOD, suspended sediments, and other characteristic contents of the sewage. So next is your sedimentation. Okay, so the settleable solids, if present in sewage effluent, will help down into the bed of the river near the outfall of sewage, thus helping in self-purification process. So what is said here is that the settleable solids, those solids which will settle down if they are present in the sewage effluents, okay, so it will settle down into what? Into the bed of the river, okay, into the bed of the river and near the outfall of the sewage, from where the sewage will flow out, okay, that is the outfall, near the outfall of the sewage, and it will help in the self-purification process. Okay, number 3 is your sunlight. Okay, so the sunlight, it has a bleaching and stabilizing effect of bacteria. So we know that the bacteria and all, they get killed, okay, by the sunlight. Okay, so here it is said that the sunlight, it has a bleaching and stabilizing effect of bacteria. It also helps certain microorganisms to derive energy from it and convert themselves into food or for other forms of life, thus absorbing carbon dioxide and releasing oxygen by a process known as photosynthesis. So photosynthesis, everyone of you know, because we have learned this photosynthesis in our school days. Yes, so everybody knows. So this process, okay, so it is known as your photosynthesis, and the evolution of oxygen in river water due to sunlight, it will help in achieving self purification through oxidation as given below. So this while this photosynthesis process is going on, that the evolution of oxygen in the river, okay, due to the sunlight, it will help in achieve the self purification process through oxidation. Now what is oxidation and reduction? There is a process. So these all go hand in hand. Okay, so oxidation, it is your the oxidation of the organic matter present in sewage effluent. It will start as soon as when the sewage, it will outfall into the river water. Okay, that contains what? River water contains? It contains dissolved oxygen. Now the deficiency of oxygen that is created, it will be filled up by the atmospheric oxygen. Okay, nature, it has oxygen, so this deficiency of oxygen, it will be filled up by the atmospheric oxygen. Now the process of oxidation, it will continue till the organic matter has been completely oxidized, and this is the most important action responsible for affecting the self purification of rivers. Okay, so last is your reduction. So reduction, it occurs due to hydrolysis of organic matter settled at the bottom, either chemically or biologically. So it occurs due to hydrolysis of your organic matter that is settled at the bottom, either chemically or biologically. Then anaerobic bacteria will help in splitting the complex organic constituents of sewage into liquids and gases, and thus they will make a way for their ultimate stabilization of the oxygen. Okay, so now these are the natural forces, okay, you remember. So now we have two numericals, very simple numericals we have regarding your the concentration of the mixture of sewage and river. So we will use that CSQS formula and we will find out the answers. So number one question is your the sewage of a town is to be discharged into a river stream. The quantity of sewage produced per day is 8 million liters and its BOD is 250 milligram per liter. If the discharge in the river is 200 liter per second and if its BOD is 6 milligram per liter, find out the BOD of the diluted water. So here what is the sewage, the discharge of the sewage, it is said it is to be 8 million liters. So you convert 8 million liters into liter per second first. Okay. So if you convert it to liter per second, so it will be like 8 into 10 to the power 6 divided by 24 into 60 into 60. Okay. So you convert it to first million liters to liter per second. After that, what is the discharge of the river mentioned here? If you read the question properly, you will get the discharge of the river. It is given your 200 liter per second. Okay, then what is the BOD of the sewage? BOD of the sewage, it's mentioned in the question as 250 milligram per liter. Okay, then similarly, what is the BOD of the river? It is given as your 6 milligram per liter. Okay, so all these values are given. Now you have to find out the BOD of the diluted water. So you use the equation. Okay, BOD of the diluted mixture you can find out by using the equation. So C is equal to CSQS plus CRQR divided by QS plus QR. Okay, so now everything is given. What is CS? CS is given as a 250. Then what is QS? It is your 92.59. What is CR? It is your 6. Okay, what is QR? It is a 200. So every value is given. You just need to find out the BOD of the diluted mixture. Okay, now you can find out easily. The next is your the same numerical. Okay, the same numerical. Here it is just written here that what should be the river discharge if it is desired to reduce the BOD of the diluted water to 20 milligram per liter. So here it is given that the BOD of the diluted water, that means here C is given. Okay, capital C is given, it is given as 20 milligram per liter. Now you need to find out the QR. Okay, discharge, river discharge you need to find out. So that is your QR. So again using the same equation and every value is same. So you use everything and you find out QR now. Okay, so you by using this BOD equation of the mixture, so you can find out the river discharge. Okay, so the answer, final answer is your 1521 liter per second. Okay, very simple numerical. You just go through once, 1 minute I am giving you. See. Okay. I hope it's clear now. The numerical is very easy. So next, Okay, so next one is also a numerical. It's a little bit big numerical. It comprises of all your like reoxygenation, deoxygenation we have studied. So it comprises of all. Okay. So the question is: a city discharges 1500 liters per second of sewage into a river stream whose minimum rate of flow is 6000 liters per second. Then the temperature of the sewage as well as water is 20 degrees Celsius. The 5-day BOD at 20 degree for sewage is 200 milligram per liter and that of river water is 1 milligram per liter. The DO content of sewage is 0 and that of the stream is 90% of the saturation DO. If the minimum DO to be maintained in the stream is 4.5 milligram per liter, find out the degree of sewage treatment required. Assume the deoxygenation coefficient as 0.1 and reoxygenation coefficient as 0.3. Now, this question, okay, there is one table and where the saturation DO value has been found out for certain temperatures. Okay, so there is a fixed table and the values are already being found out. So here it is mentioned that the temperature is 20 degrees Celsius. So the saturation DO, okay, there are saturation DO, the value for saturation DO at 20 degrees Celsius, it's already been found out and it is 9.17 milligram per liter. Okay, this one you can remember. Okay, you can memorize this value. So this is a fixed value. So the saturation DO at 20 degrees Celsius is found out as 9.17 milligram per liter. Okay, so now what you need to find out first, you need to find out the DO content of the stream. So what is the DO mentioned in the question, that the DO content of the stream, it is like 90% of the saturation DO. Okay, so now we have the saturation DO value, it is your 9.17. so if you do 90% of 9.17, you will get 8.25 milligram per liter. Okay, this one. Just wait. Okay, so you got the DO content of the stream as your 8.25 milligram per liter. Okay, 90% of the saturation DO, so you have calculated and you got it to be 8.25 milligram per liter. Now we will find out the DO content at the starting point. Okay, like when there is no disposal or there is no discharge of the sewage, when T is equal to 0. So we will find out the DO of the mix at the start point. So the formula just now we have done CS QS plus CR QR divided by QS plus QR. So the same formula you will use and the values are already mentioned here. Okay, in the question it is already mentioned, like it is 8.25. Okay, like wait, let me see. Okay, this 8.25 CS. Okay, this is the CS. And what is CS QS? QS is 6000 is given. Okay, this one. Then CR, it is 0. Okay, DO content is 0 mentioned in the question. Then again it is 1500 QR. Okay, so everything is given. So you put these values, okay, in that equation, and then you will get the DO of the mix to be 6.6 milligram per liter. Okay, so now you find out the DO, initial DO. Okay, you find out the initial DO deficit. So what is the formula for initial DO deficit? It is your saturation DO minus DO of the mixture. Okay, saturation DO saturation DO minus DO of the mixture. If you do, you will get the initial DO deficit. Okay, that is D naught, and if you minus it, so you are getting the final as your 2.57 milligram per liter. So now the minimum DO that is to be maintained in the stream, it is already given in the question as your 4.5 milligram per liter. Now you find out the maximum permissible saturation deficit. It is also known as your critical DO deficit. Okay, that is your DC. Why we are finding out all this? Because we have this equation. Okay, one equation is there, this equation you see. Oh acha, just wait, this equation, before going to this equation, let me see if I have missed out one thing. Oh yes, I have missed one note before going to this numerical. Okay, we will do this numerical in the next class. Okay, because there is one formula. Okay, if before, without going to that note, you cannot understand this formula. Okay, so till here, you, I think till here you have understood, because everything is already, just now we have explained only that formula we are using. But this formula, it is in other documents. So we will start from here. We will start from where we left today. So in the next class. Okay, but now let me uh, okay, I have to go through this. Okay, I have to go through this note first. Okay, no problem. So this one is your like zones of pollution in a river stream. So when the river it is polluted, okay, when it is polluted with the discharge of the sewage effluents, so this river stream, it undergoes certain zone. Okay, it undergoes like the river which is undergoing the self purification, it is having 4 zones. So what are those zones? Number one is your zone of degradation, number two is your zone of active decomposition, number three is zone of recovery, and number four is your zone of cleaner water. Okay, so let us see what is zone of degradation and zone of pollution. Zone of degradation, it is also known as your zone of pollution. So this zone, it is like just a length below from where you have just discharged the sewage into the river stream. Okay, this is just a certain length just below the point where you just discharge the sewage into the river stream. And also this zone, it is characterized by like the water, it becomes dark and turbid with the formation of what, sludge deposits at the bottom. Okay, and here the DO, it is the DO, the dissolved oxygen, it is reduced to about 40% of the saturation value. And also there is increase in carbon dioxide content, then also the reoxygenation occurs but is slower than the deoxygenation. Now what is reoxygenation? From the name itself you can see this is the addition of oxygen, and deoxygenation is what, it is the like you decrease the value of the oxygen. Okay, remove the level of oxygen, that is known as deoxygenation. So now the next one is your zone of active decomposition. Okay, so what is zone of active decomposition? From the name itself, it is active. Okay, it is active. That means this zone, it is due to very heavy pollution. Okay, this zone is like marked by heavy pollution, and also it is characterized by this zone. How will you characterize? It is characterized by the water that it becomes grayish and darker than in the previous zone. Okay, so here your DO concentration, it falls down to zero. Okay, and then what happens when it falls down to zero? Anaerobic conditions may develop with the evolution of gases like what? Methane, carbon dioxide, hydrogen sulfide gas, etc. Okay, there are many gases, the evolution of gases, and then bubbling to the surface with masses of sludge deposits forming an ugly scum layer at the surface. So due to this evolution of these gases like methane, carbon dioxide and also what happens that at the surface of the river stream or at the surface of the receiving water, so a very ugly scum layer, okay, like oily surface or a scum layer you can say it, we can see, okay, we can see a sludge forming an ugly scum layer. So now as the this decomposition, as this organic decomposition, it reduces down due to stabilization of what? Organic matter. So the reaeration, it again happens, and then DO, it again rises to its original level. Okay. Now, in the next one is your zone of recovery. So from the name itself, it is recovery, like it is trying to recover something. Okay. So in this zone, what happens? The river stream, it tries to recover from its degraded condition to its former appearance. Clear? So since in the zone of active decomposition, the river water, it was so much polluted. So now in this zone of recovery, the river stream, it tries to recover from its degraded condition or to its former appearance. Okay. So now the water, it becomes clearer, and so the algae appears while fungi decreases. So here the algae reappears and the fungi, it decreases. Okay, then BOD, it falls down and the DO content, it rises, and 40% of the saturation value. So the DO content, it rises above your 40% of its saturation value. Okay, so this is your zone of recovery. Now next one is your zone of cleaner water. So what is zone of cleaner water? So in this zone, the river attains its original conditions with DO rising up to the saturation value. So recovery ho gaya. So after recovery is done, so now the zone is clear. Okay, the zone is clean and clear, and so in this zone the river, it attains its original conditions with DO rising up to the saturation value. So water becomes here the water, it becomes attractive in appearance, and then usual aquatic life, it prevails there. Then some like pathogenic organisms, they might still be, like active there, but however survive and remain present, which confirms that fact that when once a river has been polluted, it will not be safe to drink unless it is properly treated. So it is obvious thing, isn't it? When a river, it gets polluted once, so that river, that total purification is not possible. Okay, it is not possible, and it will not be safe to drink that water. Yes, unless it is properly treated. So this is about your zones of polluted water, okay, or zones of pollution in a river stream. Okay, so just wait. Okay, so let us end it here today. Okay, so this part I will complete in the next class, this one, and also we will do the numerical also. Okay, so let me take your attendance. Roll number 69, then roll number 51, roll number 51, 52,
Present, ma'am. 52.
okay, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61,
61 present, ma'am.
okay, 62,
Present, ma'am.
okay, 63,
Ma'am, 63.
64, 65, 66,
Yes, ma'am.
okay, 67,
Yes, ma'am. 67.
okay, 68, 69, 70,
Present, ma'am. 70.
okay, 71,
Present.
okay, 72,
Present, ma'am, 72.
okay, 73, 74,
Present, ma'am. 74.
okay, 75,
Present, ma'am. 75.
okay, 76,
Present, ma'am.
okay, 77,
Present, ma'am.
okay, 78,
Yes, ma'am.
okay, 79, 80, 81,
Present, ma'am, 81.
okay, 82, 83,
Present, ma'am, 83.
okay, 84,
Present, ma'am.
85,
Yes, ma'am.
okay, 86, 87,
Yes, ma'am.
okay,
7.
okay, 88,
Ma'am, 88 present.
okay, 89, 90,
Present, ma'am. 90.
91,
Present, ma'am. 91.
okay, 92,
Present, ma'am.
okay, 93,
Yes, ma'am.
okay, 94,
94 present, ma'am.
95,
Yes, ma'am.
okay, 96, 97,
Present, ma'am. 97.
okay, 98, 99, 100,
Yes, ma'am.
okay, 101,
Present, ma'am.
102,
Present, ma'am.
okay, 103,
Present, ma'am.
104,
हम कुछ किया क्या
104, 105, 106,
Present, ma'am.
107, 107 is present,
Ma'am, 107.
okay,
Ma'am,
108,
107.
okay, 108, 109,
present ma'am
okay, 110,
present ma'am
okay, 111, 112,
Yes, ma'am.
okay, 113, 114, 115, 116, 117, 118, 119, 120.
yes ma'am
Okay. So, anybody is left out?
Ma'am, 84.
84.
ma'am 103 ma'am 57
84 is, I have given. 103 is given. I have given
ma'am
103.
57
57.
yes ma'am
57. Okay, 57.
ma'am 91
91. I have given. Okay. Okay then, see you in the next class, that is on Friday.